Welcome back to school. It is after Thanksgiving break, and it is crazy to think that we only have like 3 weeks left, and then we have Christmas break. So we're gonna like crunch through a few things in those 3 weeks. Starting today with Lewis dot diagrams and ionic bonding. Now let's think about like where did we come from in order to get here. We talked a lot last week, like a little bit the week before, about potential energy of atoms and the kinetic energy of atoms and what has to happen in order for atoms to bond, right? We talked about how the potential energy has to be at its lowest point, the forces of attraction and repulsion have to be balanced, and we have to make sure that those atoms that are trying to bond don't have too much kinetic energy, and so they have to transfer some of it to other atoms within the system, and if they do that, then they're like so hunky-dory happy that they're going to like form this bond and keep this bond, right? That's what we ended with last week. We're going to get into a couple of specific types of bonds this week. The two types of bonds we're going to be talking about is ionic bonds and covalent bonds. And like I mentioned earlier, we're going to start with ionic bonds simply because I think these are like the easiest to really think about. A couple things that we need to review before we really get into ionic bonding. The first thing is valence electrons. So remember, valence electrons are the electrons that are in the outermost energy level of an atom. They are the ones that are going to be either given up or they're going to be the ones that are taken in order to make an atom stable. Remember that on the periodic table, the group number is your hint towards how many valence electrons an atom actually has. So, for example, all of the elements that are in group 1 have 1 valence electron. All of the elements in group 2 have 2 valence electrons. And then I like this picture because it shows you that if you just like skip over the transition metals, then you jump into like group 13, which like the 3 and 13 matches the fact that it has 3 valence electrons. Yeah. And then like group 14 have 4 valence electrons, group 15 have 5, and then 6, 7, and then the noble gases have 8 valence electrons, right? So there's your like 2-minute review of valence electrons. Now, valence electrons are important to know when we talk about bonding because those are the electrons that are involved in bonding. Now, there's this thing called Lewis dot diagrams that are a very easy way for us to like represent valence electrons of an atom without having to draw out the entire Bohr model of the atom. So take a look at these pictures here. This is chlorine, right? And we know that chlorine has an atomic number of 17, which means it should have 17 electrons distributed amongst its energy levels. It's in group 17, which also means it has 7 valence electrons. Now imagine having to draw out this Bohr model if you wanted to simply talk about its valence electrons, right? Like it's a kind of a pain in the butt. So we do these things called Lewis dot diagrams. We use dots to represent the valence electrons, and we arrange them around an element symbol, just like you see here, just so that we can say very clearly and easily that chlorine has 7 valence electrons. It needs 1 more in order to be stable, right? There is method to the madness that is Lewis dot diagrams. You can't just like place them all willy-nilly around the element symbol. Like there's an actual pattern to it. So the pattern is that, I'm going to skip ahead to the steps here. I imagine like there's a box drawn around the element symbol itself, and you're allowed to put 2 electrons on each side of that box. All right. Now you have to like find a starting point, and you put 1 electron on each side of the box until you've gotten all of your valence electrons accounted for. So if we're looking at phosphorus, phosphorus is in group 15, which means it has 5 valence electrons. So I'd write the P for phosphorus. I would start here. I'd place my 1 valence electron. I'd go to the next side. I'd place my 2nd valence electron. Go to the next side, there's my 3rd valence electron. Go to the next side, there's my 4th, and then I can start doubling up. I return to that original side, I place my 5th valence electron. Now that's the Lewis dot diagram for phosphorus. We can do some more practice though. Here's 3 examples. So we've got calcium. Calcium, I'm looking at the periodic table over here. You could go to ptable.com. But calcium is in group 2, which means it has 2 valence electrons. So I'm going to use this guy. I would start wherever I want. I'm going to go 1, and then I just rotate clockwise 2, and then that's all the valence electrons that calcium has. So that's all I have to do for the Lewis dot diagram for calcium. Now, the more that you do this, you guys, you're going to get like more used to what elements have what style, like what pattern of Lewis dot diagram. So like calcium, I know only has 2, so I place the dots more centered on each side. You'll get there if you're not there already. All right, let's do another example. Aluminum, I'm looking at the periodic table. Aluminum is in group 13, which tells me that it has 3 valence electrons. So I'm going to take my electron, start on whatever side you want. There's 1. Go clockwise to the next side, clockwise to the next side. There's 3. That's all there is for aluminum. All right. The next example, bromine. Bromine is a group 17 element, which tells me that there are 7 valence electrons. So I'm going to bring this guy down. There's 1. Go clockwise. 2, 3, 4, and then return and double up. There's 5. There's 6. And there's 7. Now, like I said, the more that you get to know these elements and their patterns of Lewis dot diagrams, then you'll probably be like, oh, I know there's going to be that one last one, so I'm just going to put it in the center, kind of, right? So it's just easier for you to see and visualize when you go into actual bonding diagrams. Here's a quick look at like the first, I don't know how many elements, but like a good handful of them. Notice, right, we said like all the elements in a certain group have the same number of valence electrons, right? You guys are going to come to know these elements really well by their Lewis dot diagrams. You'll be like, oh, I know there's only 1 in group 1. You'll be like, oh, I know there's only 2 in group 2, right? And then all of like, these are the group 13, but they have 3 valence electrons and so on and so forth, right? So why do you have to know Lewis dot diagrams? Well, you're going to need it when you start thinking about ionic bonding. So let's talk a little bit about ionic bonding first, and then let's get into using dot diagrams to represent ionic bonding. Ionic bonding. We know that elements want to have 8 valence electrons. We call having 8 having an octet. Do you remember that show from like the early 2000s, the like Octomom? Is that what it was? Octuplets or whatever. She had like 8 babies. So that's how I remember octet. The oct part, like it's 8. I also just remembered, I think the German word for 8 is oct. 1, 2, 3, 4, 5, 6, 7, 8. It is. So not that that actually relates, but it might help you. I don't know. Elements want to have 8 valence electrons. That's called an octet. Ionic bonding refers to the transfer of electrons so that atoms can have an octet. What's important to remember is that in an ionic bond, one atom is going to give up electrons and become positively charged. We call those cations, remember? And one atom is going to take those electrons and is going to become a negatively charged anion. What's also critical to remember is that for ionic bonding, it always, let me say it one more time for the people in the back, it always happens between metals and nonmetals. So we're talking elements from the left side of the periodic table will always form ionic bonds with elements from the right side. We have an example down below. So popular of a choice. Sodium chloride, table salt, is made up of sodium and chlorine. So what is actually happening when those 2 atoms bond? We start with sodium. Sodium has 1 valence electron. Chlorine has 7. Sodium will give its 1 valence electron to chlorine. All right, so we designate that with this arrow shown here. What happens is that both atoms, just by doing that one transfer, both atoms end up having an octet. For sodium, notice that it's just 1 energy less than what it originally started with, but now it has an octet. Chlorine, because it gained the 1 valence electron, is now happy because it has an octet, right? So again, sodium is a metal. It becomes a cation, so it's Na+. Chlorine is a nonmetal. It takes that extra electron, so it becomes an anion, so it's Cl-. Now, once we transfer those electrons, right, then there's this difference of charge. There's a positive atom and a negative atom. And you should remember from like super basic physics a couple years back, positives and negatives are going to attract, right? And if they do that, we've officially formed an ionic bond. Those atoms are bonded together. So when you use Lewis dot diagrams to draw an ionic bond, here's some steps that you can take. The first thing that you need to consider in drawing your dot diagrams is what group is it and how many valence electrons does that mean for those atoms. So for example, potassium is group 1, which means it has 1 valence electron. Chlorine is group 17, so it has 17 valence electrons. Then you consider, okay, who's the metal? Who's going to be giving up their electrons? Potassium is the metal. It's going to give its electron to chlorine. Who's the nonmetal who's going to take it? So we draw that arrow that shows that transfer. Once you've done that, then you need to consider who's the cation and who's the anion. Potassium has lost an electron, so it becomes positively charged by 1, but we just write it as a plus sign. Chlorine has added an extra electron to its crowd, so it becomes negatively charged. It's our anion, so it becomes Cl minus. Notice that with ions, we write them in brackets. All right, so the symbol itself goes inside the brackets, the charge goes on the outside of the brackets. Once you've officially thought of all that stuff, the official compound that we've created is potassium chloride, written as KCl, all as one fell bloop, swoop. So those are ionic bonds. In the next video, I'm going to label it Lewis dot and ionic bonding practice Jamboard help. That video, I'm going to go over maybe 5 of the problems from the Jamboard. You can follow along with me, complete them on your Jamboard, and those are kind of like the handouts, right? Just make sure that you understand what's going on. The rest of those problems you need to be doing on your own before the synchronous class. The reason why, during synchronous time, I'm going to give you only 10 to 15 minutes to meet as a small group to double check you've got your answers correctly. And then I'm going to have you present 1 or 2 answers to the entire class. So you need to know what you're doing. And if you don't know, you need to ask me or you need to ask a group member. So anything comes up, feel free to email me. I am here to help you.